So let's say we have wire 1 carry current I1, so we understood wire 1 carry current, so it will create magnetic fields. So if we apply our right hand grips rules, so we let our thumb point in the direction of current, you will find out that your fingers above the wire is going into the pitch, which means that at the top of the wire, we are going to create magnetic field which is going into the pitch, Then as I rotate my hand, as I wrap around the wire my hand, I'll find out that at the bottom of the wire or below the wire, my fingers will be coming out from the pitch. So which means that at below wire 1, it will create magnetic field which is pointing outward, out from the pitch. So let's say below this wire 1, we have another current carrying wire which carry a current I2, and this current I2 is flow in opposite direction to I1. It flow in opposite direction to I1. So now you will find out that the magnetic field pointing outward created by wire 1 will exert a force on the wire 2 that carry current. Okay, so the magnetic field created by wire 1 will exert a force on wire 2 which carry current. So we apply our right hand palm rules in order to determine the direction of the force exert on wire 2. So our thumb point in the direction of current, our fingers which represent the magnetic field will be pointing out from the page. So we will see obviously our palm is facing downward. So that means that this wire will experience a force that directed downward. Okay, it will experience a magnetic force directed downwards. Alright, so how about the top wire? How about this top wire, wire 1? So we understood wire 2 carry current. So wire 2 will also create magnetic field because of its current. So wire 2 will also create magnetic field. So again, we apply our right hand grips rules. The thumb point in the direction of current. So our curved finger will show the direction of magnetic field. So we can see obviously at the top of wire 2, our fingers is pointing outward. So I draw the field on the top of the wire. Okay, so it create magnetic field out at the top of wire 2. So dekat sebelah atas wire 2 ni, magnetic field is pointing out from the page. So wire 1 is at the top of wire 2. So now wire 1 will have a magnetic field on it. So it will experience magnetic force because wire 1 carry currents. So what is the force experienced by wire 1? So once again, we apply our right hand palm rules. Our thumb point in the direction of current. Our fingers is pointing outward. Then it will be clearly seen that our palm will be facing upwards. So it means that wire 1 will experience a magnetic force directed upwards. Okay, so we can see obviously for these two wires that carry current in opposite direction, they are going to repel each other. See, wire 1, the magnetic force is upward. Wire 2, the magnetic force is downward. So for two parallel wires carry current in opposite direction, they will repel each other. So class, wire carry current in opposite direction, they will repel each other. So maybe we are wondering, then how about the wire that carry current in the same directions? What are going to happen? What force is acting on the two wires? So again, we try to see the situations together. So I still have wire 1 carry current I1. So we understood this wire will create magnetic field. So again, I apply my right hand grips rules. So thumb point in the direction of current. So I will find out that my fingers, all my fingers will curve into the pitch at the top of the wire 1. So at top of wire 1, the magnetic field created by current I1 will be goes into the pitch. Then as I wrap around the wire, my right hand, I'll find out that at the bottom of the wire, all my fingers is pointing out from the pitch. So at below the wire 1, it will create magnetic field which is pointing out of the pitch. So let's say below this wire 1, now we have another current carrying wire which carry current in the same direction as wire 1. So now the wire 2 carries current I2 in the same direction as wire 1. Then what are going to happen? So again, the magnetic field out created by the wire 1 will exert a force on wire 2 that carry current. So we apply our right hand palm rules. Thumb point in the direction of current. Fingers point in the direction of B. The B is out of the pitch. So all the fingers is pointing out from the pitch. So our palm will facing upward, showing that this wire 2 experience a force upward. Okay, then you will wondering, how about wire 1? How about wire 1? So wire 2 carry current. So class, wire 2 carry currents. It means that wire 2 will also create magnetic field. So apply our right hand grips rules. Thumb point in the direction of current. So fingers show the direction of B. So we can see obviously at the top of wire 2, our fingers is point into the pitch. So it means that wire 1, which is at the top of wire 2, will experience magnetic force created by wire 2, which is pointing into the pitch. Okay, so wire 1 will experience magnetic force. So what is the direction of magnetic force experienced by wire 1? So we apply our right hand rules. So thumb point in the direction of current. All the fingers will now point into the pitch because the magnetic field is into the pitch. Okay, so we can see obviously our palm is facing downwards. So it means that wire 1 will experience a magnetic force acting downward. So class, we can see very obviously when two wires carry current in same directions, they will attract each other. See, the magnetic force acting on wire 1 is pointing towards wire 2. The magnetic force acting on wire 2 is pointing towards wire 1. So they will attract each other. Okay, so this is the force that exists between two parallel wire carry currents. So when the current flow in opposite direction, they will repel each other. When they carry current in the same direction, they will attract each other. So boys and girls, we can determine the force per unit length of the conductor, means the wire, by using this equation. F over L is mu naught I1 I2 over 2 pi D. L refers to the length of the wire. D refers to the separation between the wire. So force per unit length, so we understood the SI unit will be Newton per meter.